Hi, everyone. So you scored 50 points out of 100 on this test. What was your z-score and how could you interpret that? Well, at the very least, you're hoping that your z-score is positive because then that would mean that you scored above the mean. So for example, if your z-score were 3, then that means that your raw test score was 3 standard deviations above the mean. In general, if your z-score is positive, then the original raw x score, or x value, was z standard deviations above the mean. Now, if your z-score is 0, then you scored at the mean. You scored the average. If your z-score was negative, then you scored below the mean. You could be sad, maybe very sad. So for example, if your z-score were -3, you did quite poorly relative to the class because that means that your raw test score, the raw x value, was +3 standard deviations below the mean. In general, if your z-score is negative, then the original raw x score, or x value, was the absolute value of z, standard deviations below the mean. So for example, in example 1, you scored 50 points on that test. Let's say that the mean on the test was 66.9 points, and the standard deviation was about 21.4 points. What then was your z-score? And interpret that result. On your calculator, work that out to 2 decimal places. What's your z-score? Right now, you should know what sign your z-score is, right? If the mean overall for the exam was about 67 points for the students overall, and you got 50 points, did you score below the mean, above the mean, or at the mean? You scored below the mean. 50 points is less than 67 points, give or take. So that means that you know your z-score is negative. If you work it out, your z-score was about 50, your raw score, minus the population mean, mu, 66.9 points, all divided by the population standard deviation, 21.4 points. Remember, we had all 100 test scores. We had the full population data set, a census. The z-score turns out to be about negative 0.79. Notice it's negative. You scored below the mean. So that's a check. You scored below the mean. So you know that your z-score was negative. Your z-score is about negative 0.79, which means you scored about 0.79 standard deviations below the mean. So if the scores are curved, if the grades are curved, you may not have failed the test, but you may have gotten a C or a D maybe on the test. But you didn't do too badly. How do you know if you did unusually poorly or unusually well? This is the usual metric. The 2SD rule, or 2 sigma rule, for unusual z-scores. So z-scores that are either less than -2, that's very poorly on the exam, or greater than +2, that's doing very well on the exam. So if z is less than -2 or z is greater than 2, then your z-score would be considered unusual. And the corresponding x values would also be considered unusual. So in other words, data values that are more than 2 standard deviations away from the mean would be considered unusual. So remember, if you score at the mean, your z-score is 0. Usual or typical values would be between a z-score of -2 and a z-score of +2. That means you'd be scoring within 2 standard deviations of the mean. So again, the typical or usual values would be inside here. But the unusually high scores would correspond to z-scores of greater than 2, and unusually low scores would correspond to z-scores of less than -2. So these would be considered the unusual z-scores, far away from 0. So remember, your z-score is negative 0.79. Did you do unusually poorly? No, you might not be happy with it, but you did not score unusually poorly. You're here. Now, how would you feel if your instructor told you that the z-score you got for a test was negative 2.52? How would you feel about that? Probably pretty badly because you scored unusually poorly. Negative 2.52 would be somewhere over there. Okay, so again, the interval of usual values would correspond to scores within 2 standard deviations of the mean. So let's say hypothetically that the test scores had mean mu equals 50 points, like in our earlier example from lesson 9, and population standard deviation sigma equals 10 points. Then the interval of usual values would be from mu minus 2 sigma, 2 standard deviations below the mean, to mu plus 2 sigma, 2 standard deviations above the mean. So that would be between 30 points and 70 points. This would be our interval of usual values or typical values. So if you scored 30 points, your z-score would be negative 2. If you scored at 70 points, your z-score would be positive 2 because you scored 2 standard deviations above the mean. 30 points, on the other hand, was 2 standard deviations below the mean. If you score at the mean, your z-score is 0. So again, for 30 points, that was 2 standard deviations below the mean, z-score is negative 2. 50 points was at the mean, z-score is 0, not 6, 0. 70 points was 2 standard deviations above the mean, z-score is positive 2. All right. So going from the x number line to a sort of z number line, okay, the z-score for 30 would be negative 2, for 40 it would be negative 1, for 50 it would be 0, for 60 it would be positive 1, for 70 it would be positive 2, and so forth. So each x score over here has a corresponding z-score, which tells you whether you're above, below, or at the mean, and how far away from the mean you are in terms of standard deviations, this yardstick. One standard deviation is like a yardstick, a measuring stick. Whether it's 10 points or maybe 13 pounds or 5 inches or 42 light years. One standard deviation is our key measuring stick. Okay, so actually for the list of 100 test scores, I actually did bother to type this out in my Excel spreadsheet. So unsorted, here they are, 70 points, 40 points, 60 points. Maybe these are sorted based on the students' last names in alphabetical order, right? And then the corresponding z-scores, which we obtained by subtracting off the mean and dividing those deviations by the standard deviation. So if you look over here, all the way down here, the mean for the original data set was about 66.9 points. The standard deviation was about 21.4 points. All right, the variation is the square of that. But then when you convert to z-scores, the new mean is 0 and the new standard deviation is 1. So for this column here, for z-scores, the mean is 0 and the standard deviation is 1. Okay, so based on that, what is the interval of usual values? So a student were to ask me, so typically, how do students score on the exam? Based on these parameters. Mu is 66.9 points. Sigma is 21.4 points. About. Well, again, the interval of usual values is given from mu minus 2 sigma to mu plus 2 sigma. The scores within 2 standard deviations of the mean. Work it out with a calculator, all right? So the mean, 66.9, minus twice the standard deviation, 21.4. Remember, multiplication precedes subtraction or addition. The result for mu minus 2 sigma is about 24.1 points. For mu plus 2 sigma, it's about 109.7 points. Now, a student might object and say, well, wait a minute. It was impossible to get 109, 110 points on the exam. So it would make sense to truncate that upper limit to 100 points because no one could score above 100 points on the 100-point exam. So that's a technicality. But since this doesn't make sense, we can truncate it at 100 points. So 100 points would be a typical value. You'd feel great, presumably, but still, it would be a typical or usual value. It wouldn't be that awesome. Sorry, relative to the class overall. It wouldn't be like an A plus in the sense that you didn't do that spectacularly better relative to the class overall. Sorry. All right. So think about it. If you scored 50 points on the test, did you score unusually low? Well, your z-score is about negative 0.79. The answer is no. It would not be unusually low. You might be getting a C or a D on the test, but you might not be failing it. However, if you scored 13 points on the test, your z-score was negative 2.52. How should you feel? Probably pretty badly, because then you scored unusually low. Yes, by that metric, the 2 sigma or 2SD metric, okay, you scored unusually low. By the way, on the Excel spreadsheet, I had Excel sort these exam scores. This might be more meaningful to you. You'll see that 13 was the lowest score on the exam scored by a student. That was the min. And there was a student who scored 100, the max. And of course, when I sort the data, that does not change the mean, the standard deviation, or the variance relative to the original data set. I'm just reordering the values. If you subtract off the mean, you get the deviations from the mean. So this blue column, notice we have negative values, some positive values, all right? So the person who scored 100 scored 33 points above the mean. The person who scored 13 scored about 54 points below the mean. These deviations average or add up to 0. This is due to rounding error, but it's basically 0. The average of these deviations is 0, but the standard deviation is the same. That's the phase where we basically recenter the data values. All right. We take z-scores. I'm basically sorting the z-scores over here. Okay. So look, the 13 points, that was a z-score of negative 2.52, 2.52 standard deviations below the mean, roughly. That's unusually low. In fact, the 13, the 14, and the 15, all these z-scores were below negative 2. These people scored worse than 2 standard deviations below the mean. So on our number line over here, okay, they were out here in this red zone over here. They scored unusually low. If you scored 28 points, that's not so hot, but that was not unusually low. If you scored 50 points, well, we said you did score 50 points. You scored a bit below the mean, but not too poorly. You scored about 17 points below the mean, about 0.79 standard deviations below the mean. So you scored below the mean, but not too badly. Here, these are people who scored about the mean. Their z-score is about 0. The mean, remember, was about 67 points. Okay, and then we get to the positive z-scores. These people beat the mean, and the person who got 100 points scored 33 points above the mean, raw, got a z-score of 1.55. But that's only 1.55 standard deviations above the mean. So although this person should feel somewhat proud, this was not unusually high. It was not a spectacularly high score. It's not an outlier by any means. All right. Next up, comparing z-scores from different populations.